everybody. So thank you for coming. So today I'll be talking about secure collaboration with Boundary, how at Verizon, particularly in the Verizon Innovation Labs, that we're using Boundary to do some of the testing with a lot of our partners. That's just a quick safe harbor statement. You can skip through that one. But I'll start with kind of giving you an introduction of who I am and what our group does. So as the introduction said, my name is Venkatesh Konanur. I'm an engineer here at the Innovation Labs in SF. We do have locations in Boston and LA, so we are cross-continental, if you want to say. But we have 4 initiatives, right? One is to be able to work with our executives on their 5G journey. Like 5G is the next transformative cellular technology, and a lot of the legacy systems that are on 4G, we're looking to onboard that into 5G, not just from a network perspective, right? I know your phone shows 5G, like that was not just a transformation, but for a lot of enterprises, we're looking to onboard the next generation of applications. So our centers serve as the focal point for executives to come and then learn about how 5G is going to transform their business. Second is to be able to support developer evangelization. Nothing happens if the developers don't actually use the tools to make developers aware of how they can leverage the network. A lot of the APIs that Verizon has built in terms of like service discovery for 5G endpoints and so on, being able to leverage that, we do some of the work tied to that one as well. And another thing, I think more importantly, I think tied to this talk today is engaging partners. So we have the executives, the customers, right? When I said executives, there are customer executives, and then there's a developer piece. But at the same time, our partners that we're working with, they're the ones that build the solutions that run on our 5G network. And they take advantage of some of the infrastructure that we deploy at our customer sites. And lastly, and I think this is a pretty nifty thing, is being able to reach out to the next generation of talent at the universities. Not only if we're looking at it from a business perspective, but from a next generation talent perspective, if the new generation knows what the 5G networks do, and it's pretty valuable for us. So moving on, talking about the crucial part here is collaboration is very important to our team. As I mentioned, we engage with our partners, we engage with independent developers, we engage with customer executives. But when it comes to actual, when the rubber meets the road, the actual work that happens, we need to provide a secure access for a lot of these people to access some of the compute that we host, right? This could be on AWS, Azure, it could be EC2 instances or nodes that we have deployed. We need to make sure that people are able to access these securely. And then we keep track of who we are onboarding, right? Especially when it comes to key sharing and so on. I'll go on that in a little bit of detail. But in this case, I'm talking about public MEC, private MEC, and managing an ever-changing user landscape. I'll explain what MEC is, and I'll also go over like what the 5G network and how the MEC kind of sits within all of that. But public being, as the name suggests, it's open to pretty much the biggest subset of users, if you want to call it. That's the public 5G network we all know and love. But then the private MEC is the dedicated on-prem compute that we deploy for our customers. And this could be particularly for secure facilities where they don't want traffic leaving the point of origination. And that's where we deploy a private network and a private MEC. And MEC meaning mobile edge compute. And I'll go to the next slide when we'll talk about how Verizon defines edge. And managing an ever-changing user landscape. Part of the nature of our team is to be very agile and very front-facing. So we meet somebody, we think they have a good idea, and then we want to onboard them and then give them resources to test on. And so we onboard new developers and partners all the time. How do you securely do that? And that's one of the pieces that Boundary helps us to do. I'll start with a brief primer on what 5G Edge is. And again, 5G Edge is an internal term that Verizon uses for MEC, for mobile edge compute. But what we essentially did is when it comes to the public MEC, we partnered with AWS, and we took a lot of the availability zones that exist in the general setting, and we took a piece of that and put it within our mobile network. And these availability zones that you can see, if you log into your AWS console, if you go to zones and you sign up for the wavelength zones, AWS calls it wavelength, we call it 5G Edge, potato. But essentially the same thing. So you have an availability zone that sits within the mobile network. Now what's the advantage here? Is the traffic is not leaving and going to the open internet. People are used to setting up tunnels, various configurations when it comes to deploying resources in the general cloud. But from a security standpoint and also from a latency standpoint, we believe that we can offer benefits that 5G network uniquely provides is by keeping the compute not exiting the mobile network, we can give a quicker, faster response time and a reliable response time to our users. This is the public network at high level. I mentioned a plethora of user devices, right? We do have trucks, we have mobile phones. That's the biggest market share, but it goes to a public core, and then it hits the public MEC. Now, the public MEC itself, one we have deployed in partnership with Amazon, it ties back into their parent cloud infrastructure. So if I log into my AWS console, in my VPC, among my subnets, I see the ones like AZ1, AZ2, AZ3, and wavelength zone 1, 2, and 3. And we have about 19 zones currently deployed in the country, and these are designed in a high-density cluster, like high-density cities, essentially major locations. And with private networks, the architecture is pretty much the same, except the compute sits within the customer site. And what's also different about it and unique is that we deploy a dedicated network. So we talk about signal strength right now on my phone. There's like 4 bars, 5 bars. But that's the public network that's accessible to all of us. Once we sign up, go to a Verizon store, get signed up for a plan, that's what you'd see. But manufacturing facilities, and as I mentioned, some of the secure facilities have a need to have their own bespoke dedicated network. And that's where we'll deploy radios at their site and then also compute in partnership with major cloud service providers like Azure, Amazon, like AWS Outpost, Azure Stack Edge. It could be any compute that the customer already has with some of the on-prem systems that they have. And this ties back into how Boundary does help and where does it come to help solve a problem for us. Is with public MEC and private MEC, there are unique challenges that come with it. When I mentioned it's a public compute resource, while the server, you can deploy it, or you can deploy the server components by going to a AWS console or setting up whatever mechanisms you have, the client still sits on the Verizon mobile network. So you have to be a Verizon subscriber to actually hit that endpoint on the inside. And same applies to the private network. Is with private MEC, you'd have to have some mechanism to be able to remote in to do a lot of the development work that you do. And here at the labs, we have access to both. The closest public MEC zone is in Sacramento. So we have resources deployed there doing some testing with partner. And also in the labs in SF, we have a private MEC, both flavors of both. We have AWS Outpost and Azure MEC with the Verizon ultra-wideband private network deployed. But then again, there still comes a point where how do you give users secure access? Towards that, the first one I want to talk about is Boundary's multi-hop worker. Is just to explain Boundary's architecture at a high level, they're worker nodes that work in lieu of jump hosts and bastions that give access to resources within a private subnet. So the worker would be the front-facing one. It's the public node that has the public IP address. And that's the only thing that you need to apply firewall rules to, right? And the Boundary client will be talking to that worker node, or if you're using self-managed or enterprise Boundary, there's a control plane that manages that as well. But essentially, the worker node behaves in lieu of your jump hosts and the traditional bastions that people use. But what a multi-hop worker does is a worker can also serve as a worker for another worker. And I said worker really fast in one sentence, but essentially, again, you can imagine from an upstream, downstream perspective, these two agents are talking to each other, and that plays a big role in a private network scenario, in a private compute resource, on-prem compute perspective, that we have a worker node deployed locally that talks to a worker node that we have deployed in our AWS cloud. And that way, we have a centralized infrastructure that can help managers give access to both public and private nodes. And I mentioned worker nodes replace a multitude of jump hosts. This was a problem for us that we work with such disparate partners, and sometimes they compete. They were market competitors. We want to make sure that they don't, by any means, come across or cross paths with each other, and none of the data gets shared. So we want to be able to keep those separate. That became quite a bit of a hassle from setting up bastions and jump hosts in the past. And also no key sharing, right? Being able to share keys externally, not a good security practice. In fact, it's frowned upon, or I say frowned upon, but somebody in IT is definitely taking it a lot more seriously than I do. But nonetheless, we should not be sharing keys externally to our organization. When Boundary has credential injection with SSH, So that means that when I give an external user access to one of the compute resources, I'm not sharing any of the keys. And their permissions are time limited, so that it's bounded, that I can have the user credentials expire within a month or two during the period of testing with none of the keys shared externally. And from a management perspective, that I have to generate multitude of keys per user with different permission levels. I can have like one master key that I manage to be able to control different segments of the compute. And here I talk about how I guess we have configured Boundary. In this case, is we're using the HCP managed version of Boundary. And so we have the upstream worker node. That's what you'd end up deploying. That sits in your public subnet with a lot of the virtual machines that are deployed within quote unquote a private subnet, but that's our wavelength zone subnet. And I mentioned that quote unquote as a private because, as I mentioned previously, those are accessible via the Verizon public network, but not really through a general ISP network. So if I were to you get assigned an IP address called a carrier IP. It is a public IP address, but I can't reach it from my general Wi-Fi network, right? So the worker node is what talks to the instances in the private subnet in the wavelength zone so that a user, when we gave it to a tester, they can sign in and access those instances that way. Because a lot of our users don't sit within a possibly location that has Verizon's 5G network. We do have offshore developers that might not have access to wireless network. Or it might be if somebody is coming in from a rural area, or if they don't have Verizon subscription, we don't want to, I guess, have them required to get a Verizon network to be able to do development on that. So those worker nodes deployed on our public infrastructure can help with that. And coming to the downstream worker node, so the downstream worker node is managed by the upstream worker node. And both the workers are configured the same way. It was pretty simple. Just have to go change a YAML script and then add the right IP address. But with the private MAC instance, the security feature is more enhanced because I don't have to open up a port 22 anywhere in a private instance. And this kind of boldens up the security and hardens it up. And the access to the private network happens to the public, the only assigned worker node, right? The only whitelisted worker node that I have to be able to get in those instances. However, the user, as you can see in the bottom portion, the provisioned user does not see the difference between any of these things, right? They don't know which is a private network one, which is a public network. All they see is a list of targets listed for them or assigned to them by the admin, and they'll be able to hit connect, SSH in, and then go about doing their development work. And Boundary served a unique role, kind of problem solving for us because of these two conditions, right? With private MEC, by definition, we want to be able to keep them secure, only have those resources accessible to the private 5G network without having that much entanglement from an external side. But from a public MEC perspective, because you can only reach those endpoints, the carrier IPs through the Verizon's public network, we had to have a solution so that the developers don't feel that friction when being able to reach those endpoints. So, parting thoughts. I get to my point pretty fast, but secure collaboration is crucial for innovation. Given the fact that we work with a lot of partners, the reason we work with a lot of partners is we want to be able to test a lot of different ideas. We want to be able to validate and prove a lot of these applications, and then the faster you move, you might be able to break a few things, but it's good to know the mistakes earlier on. And once we go through a few iterative cycles, then we can pass it on to the product team to develop further. And managing resources should be seamless by reducing user friction. I've been in phases where if I'm trying to reach something, if the bastion is down or the jump host is not working correctly, a lot of the firewall rules were not listed properly because the IP addresses of the laptop changed or they're in a different network all of a sudden. Caused a lot of friction, just caused a lot of repetitive human work, right? Being able to go whitelist certain IP addresses and so on. And Boundary can scale to both public and private. As I mentioned, the user or the developer does not see the difference between a public or a private. It doesn't hinder them. They can open their laptop, connect to their home Wi-Fi, but most of them are working remote. So they'll be able to connect to either of these resources in SF, in Boston, in LA, wherever it might be. They don't have to be locally located. And innovation teams improve their agility by adopting newer technologies. I think that's a pretty obvious statement, but something that we try to apply to ourselves is trying to use newer, more secure tools to make development more accessible and making it easier for Verizon to engage or companies to engage with Verizon. So in essence, HashiCorp Boundary helps solve us for challenges, but it can also scale in production as well. Essentially, being able to prove it here. For what the Innovation Labs does is we want to be able to test a lot of these different applications, different tools, and have them go through a vetting process. So there's definitely a potential when we do deploy some of these solutions, eventually down the road, after through the product team, when it gets deployed at customer sites, there's still a secure method for developers to be able to access them in case they need to fix a bug or something. So with that, thank you for listening, and thank you for coming.